everybody. Today we are doing a question from real analysis. The question is from Csir-Net December 2018. It is from part B. So only one of the four options will be correct and the question carries 3 marks. Let us read the question first. Consider the function tan x on the set S is equals to set of all x belongs to R such that x is greater than or equal to 0. X is not equal to k pi plus pi by 2 for any k belongs to n union set 0. Okay, so we have been given the function tan x and a set S on which the tan x is defined. Then the question says, we say that it has a fixed point in S if there exists x belongs to S such that tan x is equals to x. So this is basically the definition of fixed point for the function tan x on the set S. The equation says that any point x belongs to S will be called a fixed point if it will satisfy the equation tan x is equals to x. When this equation will be satisfied by any point in S, that point will be called a fixed point. Similarly, if you have any set say A and f is a function defined on A, then any point x belongs to A will be called a fixed point if it will satisfy the equation f of x is equals to x. So any point x in A which will be satisfying this equation will be called a fixed point in A. So this is basically the definition of fixed point. Now the question asks us, there is a unique fixed point. Second, there is no fixed point. There are infinitely many fixed points. And the last option are, there are more than one but finitely many fixed points. So we have to determine how many fixed point the function is having, tan x is having on the set S. So now we are having the set S. Okay, so let us see how the set S looks like. What are the points included in the set S? So this is the real line and say this is 0. Then in S we have included the points which are greater than or equal to 0. So all the negative real numbers will not be included. We have included all the real numbers which are greater than or equal to 0 plus they are satisfying this condition. X is not equal to k pi plus pi by 2 for any k belongs to n union 0. So if I will put k is equals to 0, I will be getting 0 pi plus pi by 2, that is pi by 2. So this point is not included. Now if I will put k is equals to 1, it will be pi plus pi by 2, so that is 3 pi by 2. So if this is 2 pi by 2, this point is included, but if I am having 3 pi by 2, it will be not included. Similarly, when we will put different values for k, we will be seeing that all the odd multiples of pi by 2 are excluded from S. So this is 5 pi by 2, this is 7 pi by 2, this is 9 pi by 2, this is 11 pi by 2 and so on. So except these circle points, and there are infinitely many numbers, okay, real numbers, except these circle points, all the other points are included in the set S, and these points will go on as we will move towards the right on the real line. So this is the set S. Okay, this is my set S. Next thing which is given to us is the function tan x. So now let us see how tan x looks like on the real line, okay, on the Cartesian plane. So this has now become the Cartesian plane. And how can we plot tan x on this Cartesian plane? So we know that the function of tan x is like this on minus pi by 2 to pi by 2, and this is how the function will look from pi by 2 to 3 pi by 2, because it is a periodic function. So this is how tan x looks. So now we are plotting the function tan x. And you can see that tan x is not touching the odd multiples of pi by 2. Okay, it is tending towards those odd multiples of pi by 2, but it is not touching those odd multiples of pi by 2. Okay, so this is how we can draw the graph of tan x. Now, after plotting the graph of tan x, in the question they have asked us to find the fixed points for tan x in the set S. So, those fixed points will be the points which satisfies the equation tan x is equals to x. So, this is y is equals to tan x and this is y is equals to x, right? The RHS is x and the LHS is tan x. We have already plot y is equals to tan x here. Now on this graph itself, let me plot the line y is equals to x. So when I will be plotting the line y is equals to x, this will be a line like this, right? This is how the line y is equals to x looks alike. And these are the points basically of the form a comma a, right? And these points which I am marking now are the points of intersection, that is the points at which the graph of y is equals to x and y is equals to tan x is intersecting, and these points are basically our fixed points. Using the graph this is how we can find the fixed points. The points of intersection of the tan x and the line y is equals to x will be giving us the fixed points. So these are the fixed points, and let us see how many fixed points are there. So if we will start, this is the first fixed point, this is the second fixed point, this is the third fixed point, fourth fixed point, fifth fixed point, sixth fixed point, and as you all might have understood till now that this cycle will not stop now, it will keep on going. We will be having infinite number of fixed points in particular as we will be moving towards the right. So let us see which option is correct. There is a unique fixed point. Option number 1 is wrong. Second is absolutely wrong. Third says there are infinitely many fixed points, correct. And fourth says there are more than one but finitely many fixed points. So this is also wrong, because as we will move towards the right, we can see that we will be finding infinite number of fixed points. So we will be having infinite number of fixed points, and option 3 is correct. And if someone asks us whether the number of fixed points is countable or uncountable, so clearly the number of fixed points is countable. So we have in particular infinitely countable number of fixed points. So this is how we can approach questions like this.